consists of two main. These dimensions are going to depend on your project details and your loading requirements. There are also 5 section lengths to best fit your project needs. The ultrasonically welded seam, where all of the connecting points are, is very important to the function of the geocell. The stronger the seam strength, the better the performance of the geocell. A strong seam allows for a heavier infill material, steeper and taller slopes, and better lifetime performance. The strength of the panel or the stripped material is also critical to the strength and performance of the geocell system. If the geocell is too stiff, the confinement properties will be diminished, and failure comes in a catastrophic mode rather than yielding over time. This granular soil key is a common main component wall is protected, and that the underperforming cable tie systems. So now we're going to have a quick discussion on the fundamentals of retaining walls and steep slopes. The GeoWeb retaining walls are very similar to other mechanically stabilized earth structures, so MSE walls, but there are some key advantages to using a geocell system like the GeoWeb to build these walls. It's useful to know the terminology of slopes versus walls. Walls, we think in terms of bearing capacity, overturning, and sliding. The biggest benefit is the ability to build a solution that fits well with the surroundings and doesn't look out of place. Steep environment. They also note erosion in this area is not protected by the GeoWeb system. Another advantage of the steep slopes is that vegetation can flourish within the geocell slopes because there's more horizontal. Walls are defined as structures with a batter of less than 20 degrees. So there's no limit to how high we can go with the fully vegetated. It can be seen how well the wall evaporated through plant transportation. So now let's enforcement, weathered rock or hard clay slopes. Gravity walls and slopes are designed and built with GeoWeb panels with a variety depths into your wall face. And as I said, no geogrids are required. Because GeoWeb gravity walls do not require that tieback reinforcement, they're more effective in areas where you have limited space for excavation. A majority of the GeoWeb walls and slopes do as with other types of geogrid reinforced MSE slopes and walls. In most of these cases, the GeoWeb material is used with front cells filled with topsoil or gravel, and then the terminology of vegetated. Most GeoWeb walls and slopes are vegetated, feeding the soil. And this can be a great benefit as well. So with that introduction, let's talk about why one would choose a GeoWeb earth retention system. Aesthetics and cost are compelling reasons. GeoWeb local grasses and plants are chosen to help ensure growth. GeoWeb walls have a lower carbon footprint for manufacturers. One of them with its natural surroundings have been proven to be able to resist tremendous earthquake came. A steepened slope nearby saw a major earthquake event, resulting in the sliding of the entire slope. And as you can see, the GeoWeb wall system sustained no damage, but the concrete flumes that were inset were broken and needed to be replaced. A rigid concrete MSE wall would have been damaged in the same way if it had been used here and could have led to significantly more perforation. So there's no hydrostatic buildup occurring behind the wall face. And reduced potential for spalling and cracking of the material in channels with limited space, such as your neighbor, all required conceived by people when you're building in their culverts, as shown in the case of the wall in this photo, is an important benefit to the GeoWeb system. There's no loss of structural integrity due to your continuous web connections throughout the entire wall. And the GeoWeb sections are easily trimmed to fit the large culvert and the sauna tubes coming down from the top. And we often hear from workers that it's easy to field fit the GeoWeb base for roads and infrastructure. So a hard armor concrete resistance to forces. Sliding can occur not only at the wall base, but at any is typically what controls it. So most potential problems can be avoided by having a good grading plan that makes sense for walls and slopes. For example, there's a tendency to use steep slopes at the top and bottom so as to minimize the height of the wall itself. Slopes steeper than 3:1 are often problematic due to instability and erosion. Therefore, steep slopes within walls should be used carefully, and additional design and details are going to be required. A better design is to increase the wall height so as to reduce the potential for slope angles at the top or toe, building the wall experience. Dead loads reinforce slopes, specifically with the GeoWeb. The GeoWeb MSE wall software was written by Professor Dov Lashinsky at the Adama. Have RISA installed or have used that program before to use our GeoWeb MSE program, but some knowledge of it may help. The program is highly versatile and can model a range of site conditions, and it can be used for both gravity and reinforced walls, including reinforced slopes. And the program performs both internal and external stability calculations. The software is completely free with annual updates with a simple user interface that walks you through all of the steps that need to be considered in a wall design. You start by choosing between a gravity or a reinforced wall so that you know what type of reinforcement may be needed. And it is very important to have a geotechnical report for the soil properties on your site to get the most accurate design. You can use assumed or standardly accepted values, but you would need to be more conservative if that's the case. And so the program is based on using our 6-inch deep GeoWeb panel, which is going to be the standard panel that's manufactured for this type of design. The program also has a built-in library of geogrids from 8 different manufacturers to choose from, so you can work with a product that you're familiar with. And there's some room for customization of the wall system, but in general, there are a set of rules that should be followed to achieve a proper design. And this software is going to help you with all of those rules. And the engineering values and how to interpret the results if something unexpected comes up. We're also happy to check and confirm your results on a second person to look things over. And it's good to remember that this is just a fancy calculator, and that just because it provides an output value doesn't mean that it's actually valid for your site. It is up to the engineer of the project to confirm that the system is going to work as intended. We do have some training guides and some simple video walkthroughs available on our website, which can help with some of the basic questions on how to use the software, as well as to go into some detail about the math and the reasoning behind how the software functions. So the program is pretty simple, but it can cover a lot of different scenarios and types of analyses. So it's a really good option for a wide variety of projects and a great way to figure out if the GeoWeb system will work for you. So a quick summary of what we covered. The GeoWeb system makes it possible to have both gravity, vegetated and non-vegetated areas, such as earthquake-prone areas, or along with technical support that can be used by a qualified